well, basically, I've written the programs for it, but I'll be going through it like really quickly for all of y'all. So I'll like go through it really quickly, and I'll explain it. I'll explain in detail, but like it's relatively simple. The programs aren't really complicated. I've used the Arduino, the Java, the wiring program for Arduino, which is default, which nearly all Arduinos use. So what happens is we have an integer variable for the LDR pin, which is pin 0, because the LDR pin is the pin value which sends values back, which sends the variation current, or if I can get the schematic back up. Yeah, this thing here, that's pin 0, analog pin 0. So we're just setting that pin. The LED pin, yeah, that's digital pin 12, so LED pin 12. Now we have void setup, that's the setup function. We begin a serial communication with the computer. So it begins at 9600 baud. It's regular, it's the normal amount. I don't recommend you change it because it takes a lot of effort. It takes a lot, you have to change the serial monitor and everything. It's easier just to leave it the way it is. And the analog reference, that's not required. It's just a reference voltage for the analog. However, we don't worry about that in this program. Then we set the pin modes. The LDR pin is the input, which is because of the sensor or the variation voltage, we need it to be an input. And the LED pin is the output, so we need to send it a 1 or 0, so it's the output. Now in the setup, we set the digital write, or we write to digital port number 12, or LED pin, which is 12. We give it a high, or a 5 volt. So what happens is, until we write another digital write to set this pin to low, it'll always stay in high as long as the board is on or supplied with power. So what happens is, we write this in the setup and forget about it, because we just want the LED to be on at all times. So we digitally write to LED pin 12 to try to send it a high signal, so it'll send 5 volts continuously, and that should keep the resistor, that should keep the LED on. And then we have the void loop. This basically loops every time all the processes finish here. It's just gonna go back and start again. So it's basically just a loop, like it says pretty evidently. And basically what happens here is we make an integer which has a value, just integer val, and an analog read. So basically what I said, it gets a reading between 0 and 1024 depending on the voltage between the potentiometer and the LDR, and we just, for the parameters, we just give it the LDR pin of 0. So basically value will hold the values between 0 and 1024, which will have the information about the intensity of light which is reflected back. Alright, and basically what we do is we just send this value, this 8-byte value across the serial port as a text. So that's all. There's nothing more to it. It's a really simple program. I think it already exists in one of the examples, but that's just to go through it really quickly. The second part is a little bit more intense. It's a processing part, or the part which makes a graph depending on the variation of the analog pin or the variation of the serial output from the board. We import the serial port library, and we create a port, the object port, which is of type serial. We have a float for the roughness. We want to measure how rough the ground is. So basically this value here will correspond to the roughness here. Int I, this is just basically to ensure. What I'll be doing is I'll be creating like a graph, like if you've seen in hospitals, like the heart graph, or the graph which measures your heart rate. It's going to be like that, just it'll just measure the intensity of light reflected back, or the analog pin value. So basically, to ensure that once it reaches the end of the window, it comes back to the beginning. I'm just using I there. And float last y, well, we'll see that later. We just need, right now it's not required, but we'll see that later. So void setup, we make a window 500 pixels by 500 pixels. we set up the port. The port is on the Windows. You're gonna have to check the COM port. However, I'm using a Mac, so what I do is generally what I'll be doing is what happens is when you connect the Arduino to your computer, then you will be able to see this thing here on the Arduino program. This thing here, you just copy that line word for word, and you copy that here, and that should just start the communication between the serial port and between the Arduino and the serial port and the program. So then basically what we do is we just this part, the port buffer until, is it waits for a new line because we're sending a new line every time here. So it waits until new line and it buffers all of the bytes we're sending it until a new line. And basically we just want to start the background here. So now we'll go to draw, which is the same as the loop, just for processing they use draw. So alright, let's start. Basically every time we set the fill to 255, that's basically white. So we want whatever line we draw, it should be white. So we set the fill isn't really required here. I just kept it because I had some you don't even need it right now. So yeah, and the stroke is the color of the stroke which we want to keep, which is 255 as well, which we're going to keep a white stroke because we have a black background. Yeah, we want to keep a white stroke to keep a good contrast between the two. Okay, now we're going to create a position, or basically what it is, it's a float for the position of what the value should be on the screen. So to understand better, we'll have a screen of 50 by 50, 500 by 500, sorry, and we need to the white stroke, or the degree of how far it is on the screen, is going to be set by this position variable here. Basically what it does is it takes the roughness, which we're gonna, the first value doesn't matter for, but after that it just takes the roughness of the roughness which we're gonna get through the serial port, and divides that by 1025 and multiplies that by height. Basically what that does is it just it takes the roughness, which is a value between 0 and 1025, and it just changes that value so that it's relative to the 500 by 500 pixel screen. Alright, now what we do is we create a line which is basically I minus 1, the current value of I, minus 1, and the last y, I in position. We won't understand that too much right now. I'll come back to it because we need a little bit more here. So basically what we're going to do is, the next thing is print line. We're going to print the roughness here. It's not necessary, but like I like to have text along with my the visual later to be able to verify this right. And like I said, the I is going to take the value of each like on a heartbeat meter, it's going to take like the value of each pixel. So every time it draws itself, it's going to go one pixel to the right, one more pixel to the right, one more pixel to the right, one more pixel to the right. So every time it gets data, basically this is I'll come back to that, sorry. Basically every time I move one pixel to the right, it's just going to add I. So that'll just keep track of where we are on the screen. This is just some basic parameters to make sure that like when I reaches the end of the screen comes back, so, and it says the background is 0, which means that it clears a complete screen, so there's nothing left, or there's no problems that come up because of that. And last y is just the position, so the last position. So every time this loops, we're gonna have last y, which will take the value of the position, and then it's gonna come back here and it's gonna take position, and it's gonna find new value position. So okay, now let's go to this function. Basically what happens is every time there's a serial event, or every time the Arduino sends a value to the computer, then this event will be called, and basically what this event does is it sets the value of roughness, the variable roughness, the float here, and it sets it to the port read string until it converts it to a float, and it basically just reads the output or the print line value, this here, which is sent to the computer, and it just saves that in roughness. Now we can see, now it makes a little bit more sense what happens here. This roughness is converted in position. Now here comes the drawing part, the line itself. what we do is we take the I position is the current position of our pointer. We take the last position of it and the last Y, or the last Y position on the screen of the pointer, or the roughness sensor position, and we take that as the previous point, and we take the new point, which is the I current position, and this position here. So basically what will happen, it'll create like a graph which can help explain, which will be a good representation of how rough a surface is. So alright, this should work. Now we're gonna go back to the board and the entire thing, and we're gonna see the whole thing working together, and it should work pretty well. Alright, see you. I'll just be back.